Hello guys, today we're working on an iMac that has an LVDS connector damaged. As you see, the that's the way the connector is supposed to look like. It has the housing, and then inside there's all these copper pins. So what happened is, I guess, when the screen was being taken off, the cable was pulled accidentally, or maybe the screen was lifted a little too sudden, and I guess the housing of the connector was lifted along with the cable because it's locked onto it. And just to specify, this is a 21.5 inch iMac, I believe 2009 or 10. It has an older connector like that. So we have already gotten a new one, and in this video we are going to demonstrate how to remove it. So we'll apply a little bit of flux here, and we'll just go and carefully remove the pins, the old pins, because we don't need them. Just prepare the pads and the whole area for the new connector. And we can apply a little bit of fresh solder. You got to be careful because there are some components right next to the connector. You want to make sure you don't accidentally take those off along with the pins. Okay, once everything is removed, I would run my iron across and like tin them with this leaded solder, just to make sure we have cleaned all the and now we are gonna clean it up with now we're going to clean it up with the wick. Okay, it looks nice. Now with a regular Q-tip and some alcohol, I'm going to clean the pads and the whole area, prepared for the new part, for the new connector. So we want to get rid of all this burned flux and inspect the pads. They seem to be all good. No lifted pads at all. The ground pads are also intact. No missing resistors. So good. Okay, so now I'm applying a little bit of fresh flux. Not a whole lot, just a little bit. We'll add a little more later. Just put it there and align it perfectly. Yeah, probably like that. It's a little better. Less light. Okay, so now it's time to start soldering it back on. And I usually try on the sides, just put a little bit of solder on your iron. Ideally you want to put solder directly on the joint, but now I want to be holding the connector with my left hand and tap one of the pins on the left, on the right, just to get a quick, and then on the left, just to get a quick joint so that I don't need to hold it anymore. Let me get a little more metal. And a bit more flux. It's already holding. I still want to support it just to make sure it's stable enough. Okay. I'll probably do the corners, the ground. Yeah, so I'm trying to heat the part as well as the actual board at the same time and feed some solder wire into it to get the best joint possible. So all the surfaces that you're soldering need to be heated evenly and heated enough for them to actually create a good joint. Yeah, I'm going to change the tip to a little bit smaller one, because now I'm going to do the actual pins. Let me see this one. Yeah, this one should do the job. So I'm doing them slowly, one pin at a time, trying not to feed too much solder in there because I don't want to bridge them. It's not a big problem if I do. It's fairly easy to clean it, but trying to avoid any extra steps that I need to take. So, and I constantly add flux because it burns out and slows down the soldering process. So I'm resting my iron on each pin for a good couple of seconds to make sure that it gets hot enough and transfers the heat through the solder onto the motherboard and creates a solid joint. We don't want any cold joints, as they call them, where it's somewhat connected, but at the same time it's dry and fragile. So when you connect the cable and pull it slightly, or maybe wiggle it a little bit, it can break that connection, and you'll have either distorted image, or there would be like some lines, or there would be no image at all. You don't want to have to deal with that later. That's why you want to make sure you get your soldering job done right, and for that you just need to use proper tools and proper techniques. So just make sure, yeah, you have the patience and do them right. And once I'm done, I usually go with either a pair of tweezers or maybe just a blade or something sharp, and try to inspect every pin by pushing it or pulling it like sideways to see if I have the right connection there. So that's also a very important part of your soldering, of any soldering job for that matter, is visual inspection. And on these jobs especially, you want to make sure you don't have any bridges, meaning you don't have any two neighboring pins somehow joining each other by a little solder blob, which can cause some not so good outcomes. And you, of course, you want to do it before you plug any power to the machine, whether it's a laptop or a desktop. Always do the visual inspection before any power is applied. Gonna run down there the line one more time. Okay, now I am going to clean it up real good, and it's time for a physical inspection. So I sprayed some alcohol on the brush, and I'm cleaning up the area as much as I can. And now I'm going and checking each individual pin to see if it's strong enough, and also inspecting for any bridges, any extra solder that I could have accidentally left on any of the pins that might cause some unnecessary connections that can cause some problems. And no, I don't see anything wrong with it. Seems pretty good to me. Yeah, no joints, no bridges. I mean, no joints, no bridges, but joints are really good. So basically the job is done. Now we just have to plug in the screen, give it a few minutes of testing, maybe tap on it slightly. When the screen is connected, like lift the screen and tap on the connection ever so slightly just to see if anything goes out. But if it passes that test, I'd say that's all, that it's all done and good to go. Just remember to be careful with these when you open the screens. Be very careful, and I guess understand that a little mistake can cause a pretty substantial damage to the board, and most importantly, it just waste, your time gets basically lost and wasted. So that's the most important thing, is try to do your job as efficient as possible, so that first of all the computer gets to the customer as soon as possible, and second of all, you save your time and frustration. So that's how this connector is done. Thanks for watching, and see you next time. Yeah, just wanted to show a close-up of the job. That's as close as my camera gets. And yes, it might be a little cleaner, but I'm just showing the way it looks, more or less. You see, it's all good. Not perfect. I mean, visually it's not perfect, but we can see that all the connections, all the pins have enough solder on them, and it should be a nice, fine, long-lasting connection that will never give us any issues unless somebody pulls on that connector again. Okay, thank you.